Hello viewers, today in this video we will discuss the differential protection scheme used in power system protections for protections of motors, generators, bus bars, cables, etc. As its name indicate, basically it work on the principle of comparing two quantities on the difference of two quantities like current and voltage. But today we will discuss with the current protection scheme. Let's consider an equipment, electrical equipment shown here to be protected with differential protection scheme. So consider the circuit source is feeding the load. At the input and output of this protected equipment, I have connected to circuit breakers A and B so that in case of fault, it can be isolated from both sides. Two CTs of the same ratio connected here with you can see the dot marking on both CTs. Before proceeding, let's revise a basic principle of the CTs, which is that when current enters the dotted end of primary of CT, the current shell must leave the dotted end of CT secondary. On this principle, we will proceed further with the differential scheme. Connect the CT secondary terminals in this manner. Connect a relay in between the interconnecting wires of CT secondaries. Now, during healthy condition, our source will be feeding load. In this manner, IL, let's say the current flowing through the load. As you can see that in this case, both the CT primary currents are same. So CT secondary currents should be the same because CT ratios are same. So as per the rule, dotted end is current is entering in the source side CT. So similarly, the dotted end of the CT secondary, the current will exit, current will leave the CT. In this case, both the secondary currents are equal. So there will be no spill current to flow through the relay, and our secondaries will flow into each other like this. This was the scheme that was this is the case that we have considered with no fault at all. Now let's consider that a fault appears in the equipment that was being protected with differential. Let's say IF is the current flowing through load. Now in this case, our source is feeding basically two components. One is going to load, one component, and second component is going to ground fault. Let's collectively call, I can call this current as I1. In this case, as we can see that the source side CT is facing the more primary current as compared to the load side CT. In this case, the CT secondary current will be I1 divided by N by CT ratio. I1, which is the total current component consisting of two components, ground fault and load component, divided by CT ratio. In this case, as we can see, the both primary currents in both CTs will be different. Now consider the secondary current of the load side CT, which is I2 by N. So obviously there is a difference in the currents in the secondary currents of CT. In this case, there will be a tendency for the current to flow through the relay. So relay will be energized as soon as relay will be as soon as relay will detect a fault. A current, it can issue a trip command to both these circuit breakers, and it will isolate the protected equipment from both ends. So once we have studied two cases, one without fault and one with internal fault. Now we will consider that how differential relay will behave, differential protection will behave with an external fault. As the basic philosophy of differential is just to protect the equipment, and it should not respond to any kind of external fault. Let's consider again the same circuit. This is the equipment to be protected with differential protection. A source feeding to equipment, again two CTs with dot terminals. CTs secondaries are connected in this manner. We relay in between the interconnecting wires. Now let's consider that ground fault appears here at this location, and IF is the current flowing through the load. In this scenario, we can see that the same primary current will be flow through both CTs. So both secondary currents should be equal. The secondary current for the first CT or source side CT is IF by N. Similarly, for the second load side CT, it's the same IF divided by N because both primary currents are same. Again, there will be no tendency for the current to flow through the relay. There will be no spill current actually. So our differential protection scheme is working perfectly with an internal and external fault. But in actual life, in real life, this is a different thing. There are certain imperfections between the CTs. As we know that there is always ratio error and phase angle errors between CTs. Here we will consider actual behavior of differential protection scheme during external fault by considering the imperfections in the CT secondaries. That is, one is the phase angle error, that second is the ratio error. Again, consider the same equipment, same circuit, CTs, secondaries are connected like this, and CT ratios are same. Let's consider again the same ground fault appear outside the zone of protection of the differential. But in this case, we can consider the actual imperfections, how it will impact our differential protection scheme. Like in the first CT, our current is IF divided by N1. N1 is the actual CT ratio or the ratio error, the current due to ratio error. Similarly, on the secondary side, on the primary and secondary both CTs, we have considered not only the magnitude difference but also the phase angle difference. For example, one is 3.3 ampere, the second CT is reading at the moment 2.8 ampere in terms of magnitude only. Not I have not taken into account the phase angle. So due to these imperfections, again there is a spill current that can flow through the relay, and relay will issue a trip command. But here we can see that the fault was actually outside of the zone of protection of differential scheme, and we were expecting, or it was designed so that it should remain stable during this external fault. But because of CT's imperfections and certain limitations, our relay operated. It means that there are some further steps need to be taken, which I will discuss in one more video. So now let's discuss what is the zone of protection of differential relay. Any circuit in between the two CTs is the zone of protection of differential protection scheme.